I'm here to see the doctor.
Sign in, please. The doctor will see you shortly.
Thank you.
Two hours later.
Your prescription should be ready in 2 hours, Mr. Hummel.
Chase Johnson, the doctor will see you now.
It's good to see you again, Chase. Good to see you. Follow me. So what's the reason for your visit today, Chase?
Well, it happened again.
Where this time?
In the shower.
Let's take a look at it. Oh, what was it that you stepped on this time, Chase?
I stepped on a tack.
Would you like to know the reason your body reacts the way it does when you step on a tack?
Sure.
The reason your body reacted the way it did, Chase, was in part due to the crossed extensor reflex. Before I go into explaining the actual reflex, I wanted to point out a few parts. So, the leg that stepped on the tack will come to represent your left leg, which is also considered your ipsilateral leg, because when it's stimulated, it's only affecting its side of the body. Then you have your right leg, which will come to stand as your contralateral leg. This means it was stimulated by a different part of the body. These three things right here will come to stand as your spinal cord. And within the spinal cord, you have different types of neurons. There's 3 different types. An interneuron, a motor neuron, and a pseudopolar somatic sensory neuron. So, before I go into explaining the actual reflex, I wanted just to give a brief definition for each type of these neurons. So an interneuron is between a sensory motor neuron relaying information for motor activity. So the ones that are this color here, that are right in the middle, are your interneurons. Then we have motor neurons, which send signals straight from the brain, or in our case, the spinal cord, straight to the muscle. So the black ones here running to the muscle, and then the blue ones here running to this muscle. Then we have pseudosolar polar somatic sensory neurons, which are a type of sensory neuron that have 2 branches, one to the spinal cord and other to the periphery, which is also known as polysynaptic, which can stand in this green one right here. So the reflex begins with the pain receptor in the foot becomes stimulated, or in other words, excitatory, by the stepping on of a sharp object, such as, in your case, a tack. A signal is sent up through this line, into the sensory nerves, through the dorsal root ganglia, which contains the cell bodies of sensory neurons, into the spinal cord, where this initial stimulus synapses with other interneurons. The spinal cord thus sends the signal in either ascending or descending order to other parts of interneurons that send the signal back out through the leg and spinal cord, back to the ipsilateral leg, where the flexor muscle becomes contracted, bringing the leg up as fast as possible from the stimulated area. Simultaneously, as the ipsilateral leg is contracted, signals from the original impulse are synapsed across the midline of the spinal cord through the ventral root of gray matter. Again, the neuron sending this impulse from the spinal cord is a motor neuron, so it travels straight to the axons of the extensor muscle. Much like the side of the spinal cord, these signals are sent in ascending or descending order to other motor neurons. This extension of the contralateral leg allows for the body to balance itself instantly as you move the injured leg away from the tack. So basically, Chase, the cross-extensor reflex is a type of positive feedback because it undergoes a process of reverberation. Reverberation is where collateral branches of axons further stimulate presynaptic neurons. Basically, this means that instead of moving your leg 3 inches to rid your foot of the tack, our bodies naturally overreact and flex a great amount. So as you can see, rather than moving 3 feet away from the thing, our foot will almost all the way contract just to get away from the tack. Finally, the leg that extends its muscle to balance our body can be characterized as antagonistic because it acts in opposition of the impact to your other leg. So as you can see, it acts as opposition to this leg rather than just for itself.